Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. Welcome to Happy Path Programming. It's just a beautiful day in Crested Butte.
And it's
some rain.
August 1st. Yeah.
August 1st.
Yeah. And 2025. Yeah, we should put the dates on these things.
We saw a beautiful rainbow last night.
Yes, we did.
Glad to have some rain up here.
Yes, we had book night last night.
Yep.
We were trying to figure out all the weird things about TypeScript, and oh my gosh, I don't know if either of you have encountered that language before, but it is I want to call it a mind F, but it is kind of. Anyway.
It comes with some baggage.
Yeah, that's probably a better way to do it. Yeah, we should interview Anders sometime and just find out what's going on.
Yeah.
So the Summer Tech Forum is coming up. And if you September 8th, the week of September 8th, and if you go to summertechforum.com, you'll find the details. We have students coming. We have some people who haven't been here for quite a while. Bill Venners of Scala fame is threatening to show up, and
so do you know what I'll be working on?
No.
And talking about at Summer Tech Forum?
No. What will you be working on?
AI, of course.
Oh, yeah. Well, that's
MCP.
That's the theme of the conference.
Oh, great. Okay.
And I said AI, obviously.
Building some agents.
But of course, the conference theme doesn't limit us to anything. We don't have to talk about AI at all, but that's what it says. So it makes it easier to sell to your manager.
So if you're interested in AI, great. If you're not, great.
Yep. Yeah. It's all good.
Okay,
so
let's kick it off.
Yes, this week we are talking to Aaron Pollack and Stephen Troxler from Meta, who are their focus is, I think your focus is types in Python.
So we're doing another one on Python types.
It just happened that way, probably because I was at the Python conference and at the typing summit, and so it's just ended up that way, and we're interested in types.
Yeah.
You want to talk
well, and
about
I've certainly enjoed. I've been writing a lot of Python lately.
Have you?
Yeah, and the types make my life so much better. So
they do.
Yeah.
They do. But apparently, not everybody's on board with it.
Yeah. So, Aaron,
not yet, but we love to hear that. Yeah. Hello. Yeah. Thanks for having us.
Yeah.
Yeah.
And anything to say about your background, what you work on, or anything you want to introduce yourself with?
Well, as you say, we are from the team that kind of focuses on types in Python. I guess more properly, we're the team that focuses on the IDE and CI experience. CI in so much as it's related to static typing. So we build the type checker. We try to make sure that it integrates with the editor. And we also kind of work with users to help get types to the level of adoption that they want for depending on what kind of system they're working on. Nice. And sometimes see if we can add types to older code bases that may not have types. That's kind of what our team generally focuses on.
When did Meta start adopting types?
Meta... Okay, well, so this will get into the history of the team very quickly.
Which we're interested in.
So types came out, I actually don't remember the exact year, but it was something like 2013 or 14, I think, PEP 484.
I think that's about right, yeah.
And MyPy came into existence. You recently had Carl Meyer from TY on, and he spoke a little bit about this. Instagram experimented with typing with MyPy a little bit pretty early, I think about 2016 or 17. But our team, the origins of our team are actually in the security org because there's a history of doing taint analysis to try to track the flow of data that is not controlled by our company into any sensitive system. We've got open source tools that do this in a few languages. And Pyre, which is our older type checker, was originally conceived as mostly a tool to do that. It had enough type inference to be able to analyze method calls, because if you don't know the types of things, you can't figure out what function's being called when you're trying to do this.
So was that predating types in Python?
No, this was after MyPy. So after PEP 484, after it was understood what the syntax would be, it was pretty early. The project started in, I think, 2017.
16 or 17, somewhere around there.
Okay, so a few years.
And it was open sourced in 2018.
Okay, and that was OCaml, right? You wrote that in OCaml?
Yes, that was OCaml.
Okay. And what was the motivation to, I mean, was it just, did it run slow or something? What was the motivation to move from, because I've heard OCaml is like the Cadillac for writing compilers. You know, it makes it a lot easier or something. But what was the, it's in Rust now, right?
Pyrefly.
So OCaml was pretty well used by the type checkers. If you've heard of Hack, which is like PHP with types, that team kind of pioneered the use of OCaml with type checkers. And then Flow, which is our version of TypeScript, also did that. So a lot of expertise in building type checkers was in that language. And so that's kind of what inspired us to start with that then. Fast forward to 2024, the end of last year, we knew we wanted to basically do a ground up rewrite. So we had the opportunity to pick a new language, and I can let Stephen get into more of the specifics on that, but that's where we decided to go with Rust.
That's fascinating, though, that the origins in some ways of Pyre was
originally Pyre, and then Pyrefly.
Pyre.
So Pyre came out of kind of the same ethos as Hack and Flow, which would make sense. Let's add types everywhere to all the languages, and so you had some teams doing that for JavaScript and for PHP, and so doing it for Python. That's cool.
Mm-hmm.
Type all the things. Yeah.
Yeah. And so then, what was it, a year or so ago, the rewrite into Rust began, and then that's called Pyrefly. Is that how that works?
Yes, that's correct.
Yeah. Mm-hmm. So Pyre had reached a point where, so it's the only type checker that can scale to Instagram. Now Pyrefly can, but it started out as a batch processor, and there were just design decisions that if you can rebuild it again that you'd want to make. I think the other big motivator was we knew we wanted to have a first-class IDE experience, and you really have to be very deliberate about the design of your type checker in order to do that. And so these were some principles that we went into, aside from choosing a new language and getting to basically start from scratch.
So you were able to bring all the learning that you had from creating Pyre to build this. Yeah,
and in some ways, new requirements. Like, so it sounds like maybe Pyre didn't have an LSP or doesn't. And
so Pyre does have an LSP. The challenge with it is that the architecture was oriented around doing a series of map reduces. It is incremental, so it doesn't do a full recheck.
Gotcha.
That would be unusable.
Yeah.
But the map reduces are still, that's a fairly slow way of doing updates. And it went through many passes of map reduces, which kind of minimized the amount of work it did, but also led to a lot of latency because you're waiting for the slowest element of each phase.
Gotcha.
And a lot of the reason why it had that structure, some of it is that it originated in this kind of static analysis framework where MapReduce for very long running processes makes a lot of sense. And some of it's the limitations of the versions of OCaml that we were running on. We needed to parallelize. And OCaml, like Python, had effectively a global interpreter lock. I mean, it doesn't have an interpreter, but the runtime until very recently didn't allow native threading. That has actually changed with OCaml 5, but we're kind of locked into an architecture on Pyre and a way of using the library ecosystem that predates OCaml 5 and threads. And that affected a lot of the decisions we made. Whereas Rust has always been, threads have always been native. There was no pull toward that sort of architecture. And that has made it easier to get good latency as well as throughput. But for the
so did you
IDE,
guys know Rust already, or did you come up the learning curve on that? How was that for you?
There's some learning curve. So OCaml and Rust are similar in some ways. Rust, you have to deal with a lot more details around ownership and memory layout. And there's definitely a learning curve there.
Yep.
The biggest thing we've had is a Rust expert helping us.
So
Neil Mitchell, who has worked a lot on build systems, including Buck, which is our primary build system. It's very similar to Bazel for people who are familiar with that. It's written in Rust, very large Rust project. And Neil spent years working on that. He knows a great deal. He's helped our team a lot because he helped bootstrap this project. Nice. And then coming from OCaml, other than things like borrowing and details of memory layout, the rest of the Rust type system is fairly familiar.
That's interesting to hear that the path from OCaml to Rust is pretty smooth.
Rust is surprisingly sophisticated for a low-level. I mean, it's not really low-level, except that you can twiddle bits, but really when you look at what you're able to do with Rust, it's a pretty brilliant design. Yeah.
It's there are some ties between them because the early versions of the Rust compiler were actually in OCaml. So the people who developed Rust were at least informed by their knowledge of OCaml.
There's some like root language model. What is it? The ML family of language, like both kind of come out of the ML family or something.
There's a name, Hindley-Milner type system. I guess something like that. Is that right?
Yes, the family includes OCaml, SML, some newer languages that I think I've heard you talk about. Unison is kind of in that family. And also Haskell. Rust is actually more like Haskell than OCaml because Rust traits behave closer to Haskell type classes, but they're still all very related.
Yeah. And I think Neil had worked on Haskell too.
Yes, he's
prior to this,
at least a primary maintainer, if not the author of the main Haskell linter.
There were definitely some conversations late last year where we're like, all right, are we a Rust team now? And especially coming from OCaml. But you can, I'm curious for your take, Stephen, but I feel like people have actually started to really enjoy it.
Yes, I think so. The toughest thing about Rust really is probably, there is some learning curve, but I don't feel like that's been a huge problem. If anything, the compile times are maybe the biggest downside. I think they're worth it because you get so much context from having a very powerful type system. As you're writing code, you don't need to run it quite as often. There is a noticeable delay sometimes between I finished writing the code and the test runs, and that to me is the biggest downside. I noted that you brought up Rock moving to Zig, and I think they were motivated by that, but their system is larger than I think ours ever will be.
They're doing a lot more than the type checker. Yeah, interesting. This is a total tangent, but is the Rust compiler written in Rust? Is it self-hosted?
It is today, yes. The early versions were in OCaml, but it's been bootstrapped for many years.
Which makes a lot of sense, Yeah, so
what's the current state of Pyrefly? Is it released and people using it? Where are we at with it?
Yeah, so we announced the alpha right around PyCon. And it's been exciting to see lots of people leaving issues on our GitHub, opening pull requests. It's probably still not ready to be in your CI, but the IDE is getting pretty far along. And we're having people use it and give us feedback and add features.
Nice. Yeah, my plan for my book is to test all of them just to be able to compare them and
it'd be great in your build process to run them all and see what the differences are.
Yeah, absolutely.
I guess that's a challenge for your book is when you have the output of a compiler, I guess would be the only place it would be surfaced. It'd be like, this compiler depends on which type checker you're using. Or I guess not compiler.
It's the type checker. It's all up front. But yeah, speaking of which, we mentioned before we got started, it's like I thought there were 4 type checkers. And you, Stephen, said, "Oh, there's more than that." So, can you tell me what the other ones are that I don't know about? And
honestly, I probably can't list them all because there are more experimental ones than I even know of.
Okay.
So the original type checker, and certainly one of the most important to be aware of right now, is MyPy, which is, that was where it began. It's written in Python.
And that's what you're using? No, you're not using it.
Unofficially was kind of defined how the type system would work just by being the original implementation for a while, until we evolved how the community thinks about things. MyPy was very important just because it got started with typing at all. I think many of the early other type checkers came out of the need to find a more performant type checker for very large code bases, because Python, we had, again, the global interpreter lock, and it's not a particularly fast language, single-threaded. And when you put those two limitations together, MyPy worked very, very well on small projects and not very well on very large projects.
Yeah.
So the next most used type checker today is probably Pyrite. And that came out of Eric Trout, who's the author of Pyrite, was working on a team that had some moderately large Python code bases, was finding that MyPy was too slow. And also, he really wanted to get a first-class IDE experience. MyPy, similar to Pyre that we discussed, was not really built for that in mind at the beginning. Yeah. They added an LSP, but it wasn't super responsive. So Pyrite was really geared toward give the best IDE experience I can.
And Eric came from the TypeScript team. So, when he came to Python and saw what the technology was like, we want a first-class IDE that integrates with your CI, so your hover and your types are the same. And so Pyrite's actually written in TypeScript, which is convenient for integrating into VS Code. But yeah, that's kind of the connection.
I guess I did, because you have to install it using NPM. Okay. Yeah. That is okay. And then that integrates well with VS Code.
Because easy to expose the LSP.
Okay. Yeah, that makes sense.
TypeScript.
Yeah.
But
it's remarkably fast on the command line.
It is quite fast, and I think it speaks to the careful design. And so that's something Eric would talk a lot about, is the design for the type checker matters a lot for the performance.
Yeah, exactly. Okay.
And then there's TY, and then any other ones to note?
Recent.
Oh, sorry. Yeah.
Recently, I don't know if you've heard of Jedi LSP, but that used to be the Python LSP basically until Pyrite came out. That is from a person named David Halter, I believe. He just announced a third type checker for Python based in Rust. And this one is called Zuban, or Zuban LS. It's not open source. I think the tagline is a drop-in replacement for MyPy. So I think that's what he's going for. And I think it's going to be paid for enterprises. So that's probably the newest one. And I think the community is watching. Jedi was a big success. And so it's exciting to see David come out with a new project.
Nice. Yeah.
What are your thoughts on the crowded type checker space in the Python world? It's probably great to scatter a lot of seeds and see what blooms, and there's the benefits.
Well, and a lot of people learning about how to solve the problem, which is good, and most of them are open source, or I guess except for Zuban, it's called.
I think it's pronounced Zuban. I don't actually know.
So.
Zuban.
Oh, I see. Zuban. I was thinking, Python without types is such a zoo. We're going to ban that.
I like that.
Yeah.
So there's the language design, the PEPs, like all
Yes.
PEPs side of things, and then multiple open source projects and others creating the type checkers. So there's some kind of collaboration through the type check community, type community, or whatever it is. Or what was the official name for it? You said it first.
Council.
Typing council.
Mm-hmm.
And then different implementations, most funded by large companies, or at least there's. It doesn't seem like there's.
MyPy isn't it just one person?
So the history of these things changes over time depending on where companies' focus are. Early MyPy development was backed at least partially by Dropbox, although it always had a large community of developers.
When Guido
not
was
all
there,
of whom
maybe?
worked at Dropbox.
Yeah, when Guido was there.
Okay.
He started MyPy, bringing Yuka on from PhD, who
Did not know that.
I think came up with the prototype.
Okay. Yeah, let me inject a question that I asked last week as well, which is, and I don't know if you have any insight in this, but it seems like to me, coming from Scala, that Python's type system is, and the syntax and everything is almost identical. I mean, the pattern matching and everything looks like Scala pattern matching to me, and all this. Do you have any insights on where the inspirations are from?
I have some. When we talk with Guido, who has not single-handedly driven things, but has often been a guiding force, especially in that he's sponsored many of the PEPs, he takes the most inspiration from TypeScript. Partly, I think, because he thinks it's addressed a similar problem of a highly dynamic language trying to adopt types. And in that sense, I think it's different than Scala because Scala is mostly a statically typed language, so the concerns are a little different. Syntactically, I think it might be true that we look a bit more like Scala. Some of that really has just come from the limitations in the language itself, though. For example, everything in Python typing basically uses square brackets.
Right.
That's partly because square brackets and the runtime semantics of that were well defined from the very beginning, and it's been fairly easy to just keep using that in new places, and occasionally have to make some changes to the parser or interpreter. PEP 695, which adds better generic syntax, was a pretty big change.
Yep.
But I think it was still simpler using the square brackets because all the mechanisms were already there. Adding an angle bracket would be fairly difficult because the current grammar just doesn't really leave an opening for that.
And visually, someone once said to me, Python's not a pointy language. So the angles and curlies,
no sharp edges.
Always, it gets some friction.
Oh, I'm completely comfortable with the square brackets. Yeah.
My take on terms of the actual features, I personally think that Python is a pretty complicated language if you're going to use its full power and try to type it as best you can, which there are limits to how far you can go. And to me, the fact that it feels a little similar to Scala, I think is just partly that Scala is a very complicated language because it chose to be, and typed Python is a moderately complicated language because it's trying to capture as many dynamic patterns that pre-exist the type system as possible.
I've come to think of Scala as an exploration in type systems. Some things didn't work out, and so Python and other languages could kind of cherry pick and go, oh, this worked, let's put this in, and these other things didn't.
Yeah, I mean, it's mostly funded out of EPFL, which is a educational group. And Martin, I think, is always looking at how they solve some very challenging problems around type systems.
Right.
So I think there's maybe just like a general evolution for many of these languages in the same like gravitational direction or something to what they support. Like ADTs are a good example where it's like, yeah, most of these modern languages now have ADTs, and it turns out ADTs all look kind of similar because someone like 50 years ago, said what ADTs should look like. So, so on the kind of adoption side of things,
Yes.
I'm curious your thoughts on how is the Python community generally feeling about types and the ability to add them? Is this only for the people who really understand types or have large code bases? Or what do we see on, I don't know, people that don't live in large code bases and don't,
because it
have
doesn't
maybe a lot of
matter to
experience with type
me the
systems?
size of program I'm creating. It helps me think about it, and I know that it's more correct. So I use
You've
it
been doing type
for little scripts, whatever.
decades.
I use them for everything. No, not for decades, but not. I mean, not like this.
Yeah.
So, like, yeah. All the people I interact with are big types fans and want everybody to use them, and have struggles getting people on board. So, like, what has your experience been with this?
Yeah, I think the tide is turning a bit. If there's something exciting about all these new type checkers, I saw this on maybe Threads or some social. Someone said 2025 is the year of type checking, and I was pretty delighted to see that.
And
I
the
like
year
to
of
hear
the
that.
Linux desktop,
Oh wow!
as has every year
So
been.
I think there is
So I think
definitely
there's
something
enthusiasm
there
growing.
where people are like, who maybe have been in dynamic languages, there's some of them that are beginning to embrace types more because the tooling has gotten better. The types are now in their language that they're using. Is that what you're saying?
So early on, and Steven's been in Python typing longer than me, so I'm curious for your take. But there's a lot of pushback to it. If you're familiar with the uncanny valley, this is something we've talked a lot about at Meta for PHP moving to Hack. Is at first you don't like it; it's slowing you down, it's unfamiliar, but then eventually you move past that, and it's hard to go back to an untyped language.
Oh yeah.
It's hard to say if most of the community is there yet. I'm kind of skeptical. We ran the survey last year, and it had a very high response rate. I think like 88% of people said they sometimes or always use types. Now, granted, it's possible only people who care about types took the survey, so I don't take this as a general view of the Python population. But it does seem like people are connecting the dots between I want better autocomplete and go to def in my IDE. I'm working with other people and I don't want to deal with their bugs. So it does feel like the conversation's changing.
Okay.
And did your survey have any data on the library adoption of types? In my anecdotal experience, most of the Python libraries that I've interacted with seem to have good type information in them. But I'm curious if you have any data on the library ecosystem side of this.
Not in the survey, but we made this script that runs and pulls the top like 2,000 PyPI packages and then does an analysis to see the type coverage and then also runs Pyrite's, I think, verify types. I can send a link. It's python-type-checking.com. But the coverage is surprisingly high, but with some notable exceptions where some just absolutely have no type coverage, like maybe 6 or S3 transfer. Some of these packages are, downloaded millions and millions of times per day, but still don't have types. The big ones like Bodo3 or requests with typeshed, they get their coverage in the 60s or 70%.
Nice.
So
what was the typeshed? Was it typeshed?
Typeshed is a centralized repository of type information. There's two things in it. And this is at least how I think of it. There's a typeshed std-lib. That's the canonical source of truth. It's a community maintained for the standard library types The standard library at the moment does not have types in the actual Python code, partly because a lot of it is extremely complicated and fairly dynamic code. So the typeshed stdlib has the best type information we know how to get, which in some cases involves very complicated overloads for those standard library functions.
So typeshed is like in the TypeScript world, there's definitely typed or whatever it is, where people started adding the type definitions for JavaScript libraries. So there's something similar in the Python space that allows this like external source for the type definitions.
Yeah, and then there's another branch of typeshed that's community maintained stubs for libraries that for one reason or another don't want to use inline types. And those eventually get uploaded to PyPI under the name of the package -stubs package name. So you can pull that down when you pull down the package, and then the type checker will be able to see.
So if I understand this right, so you can have a library and then you can have this additional stubs thing, which basically provides all of the types for that library.
Yep.
So that way you don't have to, and I think there are stub generators, right?
There are. Pyrite
tools.
will generate stubs, for instance, and there have been other, I think, one-off packages. As if there weren't enough type checkers, now your types don't even necessarily live in the same package as your repo.
Right.
And that causes other problems, right? Because you'll update your version of the package, and then the version of the stubs has to match it, and there's CI jobs in typeshed that will look for that and detect when a function changed or
this just seems like a stepping stone to get where we need to be, which is the libraries need to have the types in them. Yeah. But yeah, it's an incremental process to get
an incremental process. Plus, I can see there could be some hesitation because the type system itself is still kind of evolving. I mean, it feels like it's settling, but there could still be changes, and you could like do your library and then maybe have to do it again.
Yeah.
We've actually we've worked with a few community members who started to move their types back into their project. I think it's UJSON lib. I'll look that up because I want to shout them out for doing this. But if folks are interested, we have a spreadsheet, and we'd love help from the community if you want to help move them out of typeshed and put them into the package so that they can stay better in sync.
That's a fantastic effort. So thank you for helping people do that. Because just like if we can help people move those externalized types into their library, that's beneficial for everyone.
So on that subject, does Pyrefly or do you have a separate tool that can like insert types into your code? Automatically add types?
There are a number of tools that exist. We are working on a Pyrefly. I think it's called Autotype. Which is it's another command within Pyrefly that will try to take the type information that Pyrefly. For now, it takes whatever Pyrefly already produces through type inference and adds that. We may be able to add more powerful inference to it eventually. Pyre had a similar tool, Pyreinfer, that would try to do significantly more aggressive inference than the type checker would do. There are also community maintained tools that have attempted similar things. There have been a few attempts to use machine learning to do this as well, sometimes with feedback. There are a couple experiments trying to get the newer kinds of models to do it, but also more classical machine learning. Even 5-10 years ago, there were people trying to use just supervised learning or something like that.
Because it seems like that could really increase the help the adoption if you don't have to struggle through. If you can just check the results rather than have to figure them out yourself.
Some of this comes back to the actual data modeling, where if your library models data as a dictionary, you probably should create a data class or whatever instead. And so there's not always a good base type to that could be inferred. It may just be a dictionary, and you should add types.
Honestly, the types of typing problems that are hard for the human are still the ones that are hard for the inference algorithm or LLM. Like the easy types, the basic returns can usually get done fairly easily through automation. Like Pyrefly autotype does a pretty good job. Monkey type's been around forever, does a pretty solid job. But as you said, it's where you probably should refactor your code, or you're now unioning a bunch of things together. That's where both the human and, at least for now, the computer is frustrated.
Yeah. I think the biggest help that I've gotten is with, even though I've been exposed to generic since the C++ committee, and it's still like some of the tricky ones. It's really helpful if you have, something that can write those things for you, and then you can go, oh yeah, I see, that's right. But having to come up with them yourself is sometimes really challenging.
What are some of the things you're hearing on like this topic, like the challenges to people adopting types in Python? What is there resistance because it's hard in various ways, or what's the reasons? How do we get more people using types?
I asked about this in the survey. Let me pull up the question and see if I have some direct quotes.
Oh, that would be nice, yeah. Because the things I hear, like I have two friends who manage projects, and they both go, please write something that will help people understand and adopt this, because they can't, they have a really hard time getting their people who are working for them to do this. And
so just the mental model
of types, I guess. I mean, it is quite a departure from just saying, oh, here's a thing, do whatever you want with it. But look, the biggest argument is, well, the language doesn't require it, so why should I do it? That's
so while Aaron's finding direct quotes, which are better than anything I can give, I can speak to a few things we've seen more anecdotally. One is you need fairly advanced type system features if you're doing something like decorators, and you actually get into potentially underspecified behavior in some cases. So libraries that do a lot of things like decorators that are very dynamic, it's much harder. You have to immediately become a typing expert. There are type system features to help with that, but they're not, the vanilla, here's an intro to types sort of thing. That's a big barrier to cross. And then code bases that aren't easily expressed with types already. So, of course, you can have just dynamically typed code bases that use dictionaries. Type dicts might help with that, but they're tricky to use. Or people used to talk a lot about how Python is duck-typed. And the static Python type system is not duck-typed. So in order to express that, you might need to create a lot of protocol classes, which are the structural classes. That's a lot more than adding annotations. That's potentially adding a whole type system to express what your code already did using duck typing. And I think that's another place where you can run into challenges.
So I'll give you some numbers. 30% of respondents responded that they had some sort of objection to typing. The top one was, it's not required for my project. So I don't want types. This is me doing my thing. Let me cook. 27% lack of familiarity. That's actually something that is pretty tractable without a PEP or other things, and something our team's thinking about, like how can we make documentation better? How can we do more interactive ways of learning, especially with LLMs. It's a great tool to help you learn things. They're too complex, 23% of respondents. I like this quote. They're incomplete, leading to complexity. In many cases, when trying to accurately type in, you end up with shockingly dense, cryptic-looking code that makes the actual code hard to read, see. And that's kind of what Stephen was talking about before, is as you're adding more and more types, especially for code that's untyped. You see this a lot in AI ML, where you're unioning many things together based on the input value. The type now can become like many, many more characters than the actual code itself. And if you're not setting out with types from the beginning, adding it after the fact can actually be pretty challenging.
Yeah, there's probably a huge difference between the existing code base and the new code base in terms of if you start with types, it's probably a lot easier than trying to add them in later. So that probably makes a difference too.
It is, and there are certain things like we've been studying the TypeScript effect library, and last night we were trying to struggle our way through a relatively small piece of code, and the return type was, all of it was intimidating. And
Yeah, it is intimidating to us, and we're pretty good with types. So,
yeah. Well, a lot of that is that it uses every dark corner of TypeScript, and so we're not experts in that yet.
But I guess I could see there being resistance to types in general because of the perceived or real complexity that you may be faced with at some point.
Yeah, I think we haven't really gotten that good at pitching the benefits enough. So if you were to see, for example, a complex return value, you'd be able to go, all right, maybe I don't understand that, but I know it is doing a lot of good by narrowing what I could do with the result so that I don't get myself into trouble.
Yeah.
But I don't, I mean, until you've had that experience, it's a hard thing to just say, hey, these are great, trust me.
Still got more work to do on helping people see the value.
Yeah, exactly.
I mean, afraid of.
I think I was. You go ahead.
I can share some positive quotes too, so it doesn't have to be all doom and gloom.
Yes.
So amazing autocomplete. You just can't get the same autocomplete, especially with overloads and other things, without having types. And the expectation for languages now is you have language services running in your IDE. It finds real bugs. I've noticed this myself. I hate to admit this to the team, but I've started some code untyped with Python and then have gone back and added the type checker, and it's showing me real cases. Either it's definitely going to crash or it's a corner case I hadn't thought about.
Yes.
And that's a really awesome experience to have that tool statically tell you there's a problem. And still flexibility, right? So if you're writing Java and your Java doesn't compile, and it's Friday evening, sorry, you can't ship the code, even though you know it should work. Whereas with the gradually typed languages, you're pretty sure it works, and you want to be able to at least move on to the next phase. So you ignore it and you can move on. And I think some people still appreciate that flexibility.
That makes me uncomfortable. If the types don't all pass, I'm going, no, I can't believe that this is right if it doesn't pass.
Yeah. I use a compiler to just give me some security that I'm not going to ship something that's
with my experience with C++, because at the time C didn't really have much in the way of typing. And then we moved to C++, and all of a sudden my first experience was, if it compiles, it runs. Well, the small things that I was doing, that was true, and obviously you can't expect that in a large scale, but it was such a big step forward. And at the time, I couldn't really distinguish between, is this because C++ is object-oriented, or is it just because it's using types? But yeah, it was definitely the types.
I think it's a challenge.
Go ahead.
It's a challenge for Python because there are holes in the type system, and so it's hard to know whether it's your fault or the type checker's fault. And that can erode trust. I think one thing we can do is plug those gaps and get as good as we can at surfacing legitimate problems, and then people will trust more and be less likely to just ignore it and move on.
Yeah, I've had some experiences where it seems like if something doesn't type in one place, it can cause weird errors to pop up in other places.
Yes.
And then when you fix, you're nodding, so you've had this experience too. It's not just me, because I was going, what's going on here? I fixed this thing and then these other errors go away, which seemed unrelated. And I think maybe it just causes the type checker to hiccup. But you were going to say something, Stephen.
Yeah, I think that there is a debate that is live in the community, and you can kind of see it in the forums we use to discuss where we are and potential evolution of the language, between a camp of people who really want Python to turn into a sound language where if it type checks, it doesn't have type errors. Doesn't mean it doesn't crash, but you shouldn't get type errors or name errors, basically. And another camp that I think thinks Python kind of is what it is, and we're doing the best we can to provide catching a lot of bugs and IDE services, but we don't really expect to get to soundness. And I don't know how all that will turn out. I do think evolving from where we are to a fully sound language is, I don't know if it's possible to evolve it. I do think it's possible someday there will be a kind of fork. Hopefully not a fork as in two separate communities, but I could imagine a world where, and I don't think this will happen in the next 5 years, there's like a statically typed variant of Python that is a subset of Python, and you can hop out of it, but not easily hop back into fully dynamic. And that would be a way of providing guarantees. But you'd need the whole library ecosystem to support that. And that's a long road, if it's even possible.
Although maybe the experiment that we're doing with the GIL-free version that is now, I guess you can just now get that instead. I'm very skeptical about that. If everybody goes, oh yeah, we're free now of the GIL and everything will be great, and it's like, yeah, I don't think you
have. There's going to be a Python Enterprise Edition that's GIL free.
No, there is
statically typed.
No, you can get it now. Okay. You can get the
it's supported in 3.14 and experimental in 3.13.
But so you have to. Yeah. It's a separate build. And so you go, okay, I want to go into the world of free threading and screw around with that, and go, good luck. Okay, maybe.
I guess there is prior art to do this sort of thing, like in a totally different realm. But I was recently learning about formal verification languages like Lean, and I found that someone had taken Scala and then reduced it to a subset of Scala that could be used for formal verification and be formally verified. So that was a fascinating place of like, okay, there are places of subsets that really add a bunch of restrictions, and if what you need fits within those restrictions, then it's probably a great option.
Our sister team at Meta actually is working on free-threaded Python or no GIL. But another project they had been working on, and I think it's open source, is called static Python. And that's where you can actually use the types now for runtime. And I think that might be a big enough motivator to go into this fork that Stephen was talking about. Because you really need to have an incentive in order to make the type system even stricter. And that could be the motivator where people say, okay, yeah, if I can get actual runtime guarantees, runtime performance, then I will take on the burden of really using a much stronger type system.
Yeah, and the way that works is kind of how I would hope a fork could work, where it's a fork in the sense that the module is marked as static, but you're still in the same runtime. You're not having to fork the whole ecosystem.
Right.
Like it's just that this module says it's static. It can JIT compile in a way that uses types. It's not currently something we know how to do in a super user-friendly way. But it's the spirit of it is very similar to Python, but instead of using this other language that looks like Python, it actually just uses Python, but a very strict subset of it to do roughly the same kind of thing.
I think that it will be scaling that drives us to this. I mean, because years ago, people go, oh, well, Python, it's a toy language for small things. And then people started building bigger and bigger things with it and started running into these problems. And I think what types do, especially, is if you have chunks of code, you can plug them together a lot more easily and safely if they're fully typed. And so when you're building bigger and bigger systems, that's where I think people will be compelled to adopt types.
Composition.
Yes, yeah. Composition. It is, yes. We won't say the I word.
So, I don't know, give me a little pitch on Pyrefly. Why should I use Pyrefly? What's great about it?
So my favorite feature is definitely container inference. So you can create an empty container, throw some items into it, and see the types in real time using inlay hints get added to that inlay hint. Currently, the behavior is you can initialize an empty container, append a few items of the same type, and then later on in your code, if you try to append a new type, it'll throw an error. That's pretty neat. And I think there's more.
That's all done through inference, not through a actual type being specified on the container. Or
yes.
So instead of saying list of string, you just create a list and start throwing strings in, and then the Pyrefly inference says, "Oh, you're putting strings in." And then later you try to put an int in. It's like, nope.
But where is the line that you draw?
Where you first use.
Yeah. Okay.
So the first thing you put in it, we infer that's what you wanted. And if you wanted something else, you do need a type annotation to say what you actually wanted. Because we looked at constraint solving over the whole function, which has some desirable properties. But then if you do anything by accident, we'll just say, oh, you meant to do that too. So
right.
And that's something the Flow team in particular did a lot of user research on in kind of the JavaScript world. As functions get big, users really don't like that behavior of accepting whatever they provide, because the function can get so big that they made a mistake, but the type checker just accepts it as valid, and they might not get a type error where they actually wanted one.
Yeah, and I think the first use is also easier to think about.
Yeah.
It's just, the mental model is much simpler. Yeah, okay. That makes a ton of sense, yeah.
It's interesting to think about like different approaches to inference, and I'm sure that this may be one of the biggest places where different statically typed languages vary, is on how they do inference. So in this particular example, in Scala, you can create a list without type definition. And then if you put a string in and then you put an int in Scala 3, that actually gets inferred to a list of string or int with a union. And I don't know if that's the best way to do inference, but it just sounds like a different way than first use. So yeah, it'd be interesting to hear more from people on is this all dependent on your language that you're using, or is there really a golden standard for these inference decisions?
I think you really do have to keep in mind that, like our experience trying to figure out TypeScript, what's the difference between a const and a read-only? Stuff like that. The more that the user has to hold in their head, the harder it's going to be. So I think even though I can see the argument for going, oh, well, if you just keep putting things in, we'll keep adding to our or. First use just is a lot easier to understand. And then if you do something else, you go, oh, I have to be explicit about the type here. That, I don't know. That just sounds right to me.
Yeah, and we'd love for people to use it and give us feedback on it. But I like the trade-off personally, and it's something that other checkers can't do. But we'd love feedback from the community. So the return inference, I love. We're getting a pretty robust set of IDE features now, so you can do find all references. That took a while to build, but we're pretty happy with the implementation. And we're just now optimizing I would say we're past optimization. Basically, you can run Go to Def on any size code base. If it can work on Instagram, it probably can work on any code base out there. So I think the code nav is the thing beyond the inference that I like the most.
And you keep mentioning IDE. Is this a particular IDE that you're using or working with, or is this just the LSP?
So we're just implementing the language server protocol from Pyrefly itself. Most of our focus, just making sure it all works, is on Visual Studio Code, since that's the most used externally, and we also use that internally as our primary tool. There are people who are using Pyrefly with NeoVim and Emacs, both of which have language server plugin providers, and you can kind of hook into pretty much the same functionality.
What about PyCharm?
It works.
Does it work with PyCharm?
It does. There's an unofficial version, so community created. I tested it a while ago, and it works. We don't officially support it, but someone else does.
And there's an extension for Zed now, too, that's also provided by someone in the community, not us.
I see.
And it's in OpenVSX, so if you're using like Cursor or Windsurf or any of those VS Code derivatives, you can install it there, too.
I don't know if you can say this, but do you know what percentage of people at Meta use, or what percentage of the company is using Python?
Let me find the stat that was approved for PyCon.
Okay.
It is the most. It is the most used language at Meta now.
Wow.
Yes, and especially if you look at a monthly active, it's by far and away the most used language.
Wow.
Let me see if I can pull it up. But yeah, it is widely used.
Wow. So it's that and TypeScript?
Hack.
Hack's probably the next biggest. Yeah. The back end to the main. A lot of the web server type logic is in Hack, and that's quite heavily used. And Flow is used for the front end, which is similar to TypeScript, but not TypeScript. It stays closer to JavaScript.
Well, at least there are lots of types at Meta.
Yeah.
I think that's a good thing.
Oh, yeah. Well, but again, I think it's a scaling issue. It's like you get something that big, and how do you manage it if you don't have types?
Yeah.
Aaron, did you come up with something?
I'm looking for the approved.
Well, anyway, the most used language.
We can put it.
It is the most used, like thousands of developers per day.
Wow. Okay.
Yeah.
Nice. Awesome.
Anything else about Pyrefly that's highlight or that's coming up that would be of note?
I think the auto typing is going to be big.
Yeah.
We saw someone on. This is not related to auto typing, but someone created an MCP server with Pyrefly.
Nice.
And the idea there was to addict the LLM to adding types to a code base by using lollipops. So it was both like an experiment with adding types, but also like a weird psychology study on how to addict, like quote, addict LLMs to doing soming.
Using lollipops, did you say?
Yeah, it's worth a Google. It's pretty
I don't
wild.
know what a lollipop is.
It's if I recall, the way it works is they just tell the LLM, you love lollipops. You need to get lollipops, and we'll give you a lollipop if you add a correct type to the code base. And they just keep repeating this.
Wow. Okay, this is new.
Now we know LLMs are motivated by lollipops.
Well, no, you tell them that is their goal. Okay, this is the way that we keep the AIs from turning us all into paper clips, right? Is we just say, no, you like lollipop. Well, then they'll turn us all into lollipops.
That's a fascinating experiment.
Let's not do that experiment.
Well, not that one, but I do love the idea of getting the LLM with an MCP server that has knowledge of the types to actually start being helpful to you. That's a
so you give it this mythical objective that's lollipops. Okay, that's crazy. We'll put
And
that on. But it's
a
not. It works
feedback
with
loop,
kids too.
It is worth a Google because this person had found like different personas that they gave to the LLM based on, I think it was you're an achiever or I forget the other one, but typing aside, just as a psychological experiment, it was pretty fascinating.
Yes, incentivizing it with lollipops.
Well, and it sounds like that used Pyrefly to drive the MCP logic for what it would have knowledge of in terms of the types. So that's cool.
Yeah.
One thing I'd like to do with the MCP is maybe the auto typing feature one day, so you can now have the LLM call a tool that automatically adds types to your code via Pyrefly.
Specialized for that.
I think that could be really powerful. Yeah.
Yeah. And then agentic loop and validate that it works.
Yeah. Yeah. Well, I will be exploring Pyrefly in the future, so I'll give you feedback if I have any.
Yeah.
And the community appreciates all of your efforts in bringing typing on.
Yeah. So I use UV for my builds with Python. If I want to get Pyrefly running in my build, what do I just add some stuff into my Py project and done? What's the process?
I think you can just do UVX Pyrefly check, and that should automatically run it. Nice. Or UV add Pyrefly, and then we have an init command, which will actually copy over your MyPy or Pyrite configs as best we can. And then, from there, run Pyrefly check and give it a try.
All right.
Oh, I'll have to give it a try.
Oh, yeah, for sure.
And please do leave feedback. Our Discord is on our website. In this preview phase, we want feedback. We want to see the direction the community wants us to take it. And we'd love for people to get involved.
Yeah.
Yes.
Right.
Great. Well, thank you all. That was awesome to hear about all your great work on that. So thank you.
Thank you.
Yeah, thanks, James and Bruce. This is fun.
All right. Thank you. Bye.